Tak dobrý den.
Dobrý den.
Představím vám naši kolegyni, hezčí část scénária Martinu Koláčkovou. Mé jméno možná už znáte, jmenuji se Jaroslav Textoris. A v dnešním meetingu po nějaké úvodní části budou přítomní pan Marcin Rojek a Mariusz Kolanko. Naši partneři z Polska. Ta část, kterou povedou, bude v angličtině a proto je tady zapnutý transkript, aby, řekněme, to bylo popsáno v angličtině ty jejich slova. Ta úvodní část bude v češtině. Prosím vás, pokud budete mít dotazy, využívejte hojně chat. Samozřejmě k této prezentaci potom dostanete k dispozici i záznam, takže se na to můžete i podívat. Na chatu budeme podle možností odpovídat. Předpokládám, že ta angličtina, která bude následně použita, bude pro vás dostupná. V případě dotazu pak se individuálně můžeme spojit. Takže já si dovolím takový krátký úvod. Jak už to píšeme na slajdu, jako všichni jsme se asi už potkali s nějakou umělou inteligencí v různé formě. A já jsem měl to štěstí, že nás jako Gold partnera Lenovo pozvalo Lenovo na svoji každoroční akci do Prahy, kde právě pánové Marcin a Mariusz prezentovali jejich úspěchy v oblasti umělé inteligence a pro nasazení umělé inteligence používají Lenovo. Takže tady uděláme pár úvodních slajdíků, které jsem si připravil, aby to nebylo na vás jako úplně na ostro. Prosím vás jenom, kdyby se neměnily slajdy a mluvil jsem o něčem, co na slajdech není, tak mi řekněte. Prezentaci vám děláme v kanvě, někdy se to sekne, respektive ty týmci se seknou, s tou kanvou si úplně nerozumí. Naše společnost je váš partner v IT a umělou inteligenci používáme téměř všude, jak jsem zjistil dneska, když jsem si připravil prezentaci. Určitě vy, kteří od nás máte nasazené bezpečnostní řešení, třeba Bitdefender nebo jiné, tak je to v těch produktech, které máte. Určitě to používáme i na našem e-shopu, doporučuji ho navštívit. Používáme to v práci se zákazníky, to znamená některé informace pro vás, si pomáháme s tou umělou inteligencí. A nově ve spolupráci s firmou ByteLake vám to nabízíme jako službu. Jenom rekapitulace našeho posledního webináře na téma Microsoft Copilot a umělá inteligence. To znamená, takováhle je nějaká představa obecně Microsoftu, jak se to bude s tou umělou inteligencí, řekněme, dít. Ta představa z mého pohledu je vhodná pro uživatele a využití, řekněme, v kancelářské práci. A my se dneska budeme v té následující prezentaci firmy ByteLake zaměřovat na průmysl a, řekněme, zpracování, na takovou tu praktickou realizaci v praxi. Nebudeme teda hovořit o tom, jak vlastně to je z pohledu té kancelářské práce, administrativy. A jenom připomenutí pro nás, pro všechny ajťáky, že vlastně dneska ty procesory, které jsou v těch počítačích a desktopech anebo v těch notebookích, vlastně ty nové by měly mít 3 jakoby jednotky, které jsou na sobě nezávislé. Jo, CPUčko známe, přidalo se k nám GPUčko, ještě z dob MMX procesoru od Intelu. No a nově je tam Neural Processor Unit a její výkonnost se udává v teraflopech. Někdy za měsíc podle mě bude mít Lenovo první, řekněme, notebook, který bych si koupil, protože tam bude mít jednotku, která bude mít vysoký výkon toho NPUčka, malou spotřebu a určitě vás o tom budeme informovat. Pro jednoduchost, ještě pořád jsme v té administrativě, to, jak využívá Copilot Microsoftu. Jo, takže máme ho v Bingu, prohlížeči, ve Windowsech, jako, a pak jsou placené verze, které můžete použít jakoby jak pro osobní použití, tak pro firemní. Ty licence si u nás můžete zakoupit. Co se týče vlastně těch změn, které to přináší, tak Microsoft je silná firma a donutila výrobce, že místo tlačítka Windows tam bude teď tlačítko pro Copilota a na základě té licence se vám to bude startovat. Téma, které nám je společné, je určitě bezpečnost a vlastně produktivita. A jenom připomínám, že vlastně v říjnu končí, příštího roku teda končí podpora Windows 10 a je potřeba být na to připravený. Určitě vám s tím dokážeme pomoci. Máme to nějaké připravené, řekněme, způsoby a určitě vás budeme dále informovat. No a nyní už se blížíme k tomu závěru úvodu. A aby jsme nepřišli s prázdnou, tak zjistili jsme a zajistili jsme pro vás kontakt přes naši společnost na firmu, která vám pomůže vyřídit dotace na vaše projekty, ve kterých vy můžete implementovat i umělou inteligenci. Je to určeno pro firmy do 250 zaměstnanců se sídlem mimo Prahu. A ten projekt je o velikosti, minimální projekt asi 2,5 milionu korun bez DPH. Často s vámi anebo s jinými zákazníky řešíme, že si o dotace žádáte. Tady je velká výhoda, že ta firma si nechá za svou práci zaplatit až ve chvíli, kdy ta dotace je schválená. Znamená, pokud ten váš projekt vykazuje už na začátku nějaké vady, dokážou je odstranit, dokážou poradit a vezmou si peníze teprve ve chvíli, kdy vy na ten projekt dostanete schválení, to znamená, dostanete peníze.
Já bych možná ještě doplnila, že mají velmi vysokou úspěšnost těch překlepných dotací. To je okolo 90% asi.
Jo. Aktuálně čísla za minulý rok snad bylo, že ze 47 projektů jich měli 43 nebo 44 schválených, jako, takže velmi vysoké číslo, jak to se týče počtu podaných, tak hlavně těch schválených. No a poslední věc, na všechno mimo ty technologie, které znáte, používáte v AI, je tady Scenario a firma Whitelake. A teď předávám kolegům Marcinovi a Mariušovi slovo. A teď to bude v angličtině, ale předpokládám, že to bude pochopitelné. Určitě se ptejte, ať už chatu nebo nejlépe teda chatu. Hello Marcin, it's your presentation.
All right. Thank you for the introduction. And it's always a pleasure to do a presentation together. So thank you for inviting us. And my name is Marcin, and together with Mariusz here on the call, we're founders of the company named Whitelake. And we've been working with Scenario on establishing solution in the Czech market that leverage AI, not only AI, but also other services. But our focus for this webinar will be primarily on AI. So let me share my desktop, and if anything is unclear or you would like to ask some questions, please feel free to use chat. We'll address the questions at the end of the presentations. And if anything becomes unclear, we can always do the live translation to Czech, I guess. So we have the best friends here. You can also ask the questions offline, and the presentation, and as Jaroslav said, will be available offline. So I'm sharing the presentation right now.
I'm trying to close my my sharing, but it doesn't work. It seems. Can please maybe you can show.
I can see already the new presentation. I don't know with other participants. Oh, now it's a black screen. Oh, now it's back. All right.
Okay.
Prosíme, jestli už vidíte správnou prezentaci, my ji teda nevidíme. Nevíme, co máme dělat tady.
Can you see the full screen?
No.
I can see the full screen. What about the others? Yeah, on the chat, we can see that it's available. Michał already write the chat that. Okay. So everybody, I think.
You see that. Okay, perfect.
Yeah. So we'll talk about real life case studies of AI deployments, and we'll focus on industrial AI primarily, but we'll expand the topic a little bit towards other industries. So first of all, what is AI, right? So we probably most of the audience saw already many definitions, which we heard things like machine learning, deep learning, AI models, edge AI, large models, small models, whatever comes to the media. But for us, we think at ByteLake about AI as a bunch of algorithms that can be connected to either cameras or microphones or any other sensors. And then through cameras, AI or algorithms can see. Through microphones, AI can listen to the sound produced by machinery, for instance, or through IoT sensors or any source of data. AI can either learn a little bit of the history of certain behaviors or processes, or it can get access to the real-time data, time series data from sensors, or from online data like weather predictions. And a couple of definitions to start with. So first of all, like AI is all about capturing all the data and transforming it into information for certain reasons. We either want to do things faster, or we want to answer questions why something happened, what will likely happen, so we want to make predictions, or we want to cut costs or improve the performance of some processes, or for any other reasons analyze all the historic data, all the online data that for humans it would be difficult to do it in real time. So we have the algorithms. To make the algorithms capable of making decisions, or to make those algorithms capable of drawing insights from the data, we need to train those algorithms. So the first thing is we leverage the data, historic data, we train the algorithms, and then we turn those algorithms into models, which are trained algorithms. So when we deploy AI, we actually deploy trained models. So when you hear a model, it means that AI is trained to do something, recognize images, recognize sound, or maybe read some documents. And then you can deploy AI in the cloud somewhere in the remote destination, in the remote infrastructure, or you can deploy it on your local PC, local industrial computer, on your small PC, large server, whatever. And if you deploy it locally and all the data is transferred to your server locally, and the data is processed by trained AI, meaning model, locally, that means that AI is run or executed in edge AI environment. So edge AI is about running AI on the device locally without any need to send over the data to remote cloud or server architectures. So that's the basics, right, regarding the AI, and I believe some of you are already well aware of it. So going back to the fundamental question, what is AI? AI is about converting data into actionable insights. But from the end user perspective, why would we do that, right? So there are certain use cases that we typically address with AI. First one, most common, is about visual inspection. So visual inspection is about leveraging cameras to turn images or videos into information. And what kind of information we can read from images is again quite straightforward. We can read we can inspect visually or assess the quality of products, of components. We can count things. We can check things like you can see on the screen, read the scratches, read labels, check the color, detect paint chips peeling, wrong shape, fractures. We can read and analyze labels if they are too high, too low, if the corresponding labels at the front and the back of the product are corresponding, or we can monitor the production process. We can detect anomalies, everything that can be visually inspected like normally humans would do. Chances are that machines can do the same much faster, and by using the cameras. Then, as I said, if you connect microphones to trained AI models, then you can find and listen. You can listen to the sound produced by car engines, different components like bearings, and then you can find different nuances that might indicate that there is something wrong with any of the components inside of the car, or maybe there is some quality issue with the car engine. You can filter out noise, you can identify characteristic parts, detect anomalies, and so on and so forth. So then again, by leveraging sound, you can do a lot more in industrial aspects than just enabling the sound steered assistants like Alexa, for instance, right? And if you expand the number of sensors towards IoT, it might be sensors measuring pressure, speed of the flow of the water, or maybe temperature, or anything else that you can imagine, right? Or you can expand IoT sensors with any historic data, like data describing your processes in the factory, readings from different machinery components, or maybe online data like weather forecasting. And AI can tap into these sorts of data and then again convert it into insights or information, and help you find optimal configurations, for instance. Maybe find patterns that you should follow to reduce the energy consumption, enable predictive maintenance, detect issues before they happen so that you have time to react, maybe generate some warnings in your company, or predict sales, make some other predictions like what components you should order and when, to save money, but also to secure your supply chain. So like with AI, we're talking about transforming data that you already have or might have into information that can help you run operations smoothly and reduce cost, become more competitive in the market, improve the performance, do things faster, and there's more, right? The analysts say that by deploying AI, industries see certain numbers improving their general productivity, reducing downtime, ensuring that we have less unexpected breakdowns. We can lower the maintenance cost, and all of this, these numbers, they translate into dollars. Like, for instance, for the paper industry, which runs on thin margins, we, as reported by the International Journal of Strategic Engineering Asset Management at the bottom of the screen, you see that unplanned downtime equals $200 US per day at the pulp plant, right? At the manufacturing sites, it can be even like triple the number, right? You see the breakdowns go down by 70% by just employing IoT and AI combined. Less downtime, it's clear, right? Because we can steer the machinery with AI to ensure that it runs in an optimal fashion, and we can predict issues before they happen. So that again translates into more durable and reliable infrastructure. With all of this, we also hear similar numbers from our customers. For instance, one of our customers recently reported that they improved the performance of their back office team by 7x just by improving the processes related to document processing. So that's quite a number, right? And that helps you offload your team from repeatable, daunting tasks, so that they can focus on more creative stuff rather than, for instance, read the documents and fill in the papers in your ERP system, which can be done automatically by AI. But anyway, these are the numbers we get from analysts from different industries, and more or less the numbers are the same in our deployment, and that's what AI brings as a promise, right? But just to give you the real life examples. So let's focus first on the computer vision or machine vision case, where we leverage the camera, industrial camera that you can see on the left-hand side, that can monitor a production line and either count objects or detect or analyze their quality. What you do in edge compute design, you connect the camera directly to industrial PC, which can look like the one on the example SC50 from Lenovo. And then AI is 100% fully deployed purely on this device. So there's absolutely no dependency to any cloud service or any third-party provider. Data, meaning images or videos, is transferred in real time through local network to that PC, which has trained AI model that is capable of detecting either quality issues or maybe read labels. The use case is really up to you, what you train AI for. But the intention of this slide is to show you that the deployment architecture can be really simple as a camera plus a simple PC powered by Intel i7 CPU. And then in almost real time, the data can be, meaning images can be turned into information, which can tell you a few things about the quality of your products, or count it, or automate inventory process. Small form factor, really tiny device, operating in difficult environments. Typically, these industrial PCs are, dust resistant. They can work in extreme temperatures. They have wireless options, so the camera can be as well IP camera. Scalable architecture. All of the solutions that we're talking about are fully scalable. So if you want to start with a single camera and then continue towards 10 cameras or 10 production lines or different multiple sites, that's absolutely doable. You just plug and play another PC and connect to another camera. If you want to connect more cameras, you can replace the tiny PC with a little bit bigger edge server, which can take GPUs or server CPUs like Xeon CPUs from Intel. That's completely scalable. And in this example, we're automate the quality inspection, right? So, and you can read more about that by clicking the link at the bottom of the screen. But visual inspection is not just about monitoring single products. It's also about monitoring the whole processes. As you can see on the right-hand side of the screen, the beginning of the line and end of the line marks the beginning of what's called the wet line or water line. It's very specific to paper industry. At the bottom on the left-hand side of the screen, you see the paper making machine. And the long story short, although the process is quite complicated, the paper production looks like you pour the pulp on a table, and then you gradually dry it out until you get the paper. But the natural process or a phenomenon occurs, which is called the wet line, which needs to be monitored in some environments. And the wet line monitoring is used to monitor the quality of the paper and to avoid the breakdowns in the company, to avoid the downtimes in the company. So when the wet line, for instance, gets too close to the rolling machine, the paper might break, and then you need to stop the process, clean the machine. If it's too far, the paper might be too dry, and there might be certain fractures on the paper. But anyway, like the process is typically done manually. And by the way, this case we deployed together with our partners in Czech Republic. So it really has a bit of a local flavors. And then what we do there, we again offloaded those persons from, really boring job that you need to just walk around the machine every 15 minutes, maybe 10 minutes. Nobody knows, right, how often you should do that. Maybe 1 hour will be enough at some point, but then you come 5 minutes too late, and it might be already those 5 minutes too late, or maybe 1 minute too late. But anyway, we installed the industrial camera, again, connected to tiny PC with i7 processor, and then in real time, we monitor the paper making process, and then AI every couple of seconds, minutes. The process is quite slow, so in this case, it doesn't have to be even near real time. AI takes pictures and detects the wet line and sends information about its size and position to the operating room, and then based on that, they can make decisions like if they want to adjust the paper making process or make another decision. Something you can read more about in our case study. You can also download the white paper and some credits to the pictures at the bottom. Anyway, going forward to sound analytics, not so common use case for industrial settings, but we're there as a company, and typically we understand that AI plus sound analytics equals Alexa, for instance, or any other Siri, whichever you use. But in industrial settings, we typically use microphones, on an array of microphones, to monitor the quality of car engines, or we can monitor clutch, we can monitor the bearings, and any moving parts that can be diagnosed by analyzing the sound they produce or generate, right? So with a very simple solution, you can enable cost-effective device that can help you predict or proactively suggest quality issues that might occur in your environment. Again, like for other cases, this solution can work 24/7, can be monitored continuously. So if it stops working for any reason, then it can send a notification through cloud to ByteLeg or scenario support team, and then someone will remotely fix that for you. But anyway, AI works again offline, 100%, on the edge, meaning that there's no any dependency to virtual machines or any cloud subscriptions or whatsoever. But again, if you want to deploy that on a virtual machine, that's fine, right? But what we typically do, we install a PC in a production line in a closed environment, so there's no risk of leaking your data, no security issue, and again, we can enable that the AI really works for you in offline environment and is completely independent of access to the network or internet, if you like. And then combining all of this together, meaning like video, sound, but really IoT, it can turn historic data, online data, like I said, the weather forecasting, for instance, image, video, sound, other, into predictive maintenance settings. We can monitor machines, processes, or the whole infrastructures. Data analytics can also enable optimizations. It can help you reduce the energy consumption, detect patterns, help you manage dynamic pricing, and make better informed decisions, right? So really like data-driven approach. So we all generate the data, right? Most of us collect the data for any reason, right? Sometimes it's legislation, sometimes it's for hobby, other time we archive the data, right? So anyway, with the data and with the plethora of data that we already have somewhere stored in our servers, AI gives the promise that finally the data can be leveraged, and whatever new data is generated, it can be added on top of the data that we already have. And then with all of this, we can make better informed decisions and really enable data-driven decisions in our organizations. On the left-hand side, you can see plethora of sensors, but other options available. You see a few examples of hardware like SE450, SE350, SE50. These are from Lenovo portfolio, but really what we are compatible. Our solutions are compatible with all Intel, all NVIDIA, all AMD. So any type of combination of PCs or GPUs or CPUs you might imagine or you might need to enable the performance and reliability or just to meet your preference. Our products are compatible, and we release the white papers summarizing their performance. But anyway, whatever size of a company is, the partners like Scenario can help you pick the right infrastructure to meet your performance requirements, reliability, local preferences, and whatever other aspects you might have. And Edge AI will be compatible with this. Moving forward to a more complex case, which is for the energy utility company, which we did just recently. This is one of the huge AI deployments that we've done for the for the city in northern Poland. What you can see on the screen here. Let's go from top left corner. On the left-hand side, you see a typical infrastructure in a smart city or smart factory setting. There is a heating infrastructure. There is some energy distribution infrastructure, right? In the middle of the screen on top, you see energy utility company, which has certain goal. It needs to order certain heat or energy from energy plant on the right-hand side on top, or heat plant, and then distribute that energy in an optimal fashion to cities and factories. And there are certain goals those companies want to meet. First of all, they need to secure that they deliver heat, meaning temperature or energy, to each node of the city, meaning each flat, apartment, house, factory, warehouse, whatever we have in the city. But they need to do it optimally. So if they want to be on the safe side, they would order as much heat as possible, distribute it, and then remove the remaining part as a waste. But then the cost would hit the roof on their side, and basically they would not run their own business optimally, and they would be out of business pretty soon. If they want to be on the safe side, put the cost on the safe side, they can order as little heat as possible, and then distribute it. And if it's not enough, they would hang up the phones with the complaints, basically. So they constantly monitor the weather, the dynamic pricing, the demand, the supply, and any other factors like indications or schedules from factories, city councils, and so on. And then based on that, there is a very advanced team that monitors what heat they should order under what circumstances. And they store the data in a database called SCADA, which is a standard in the industry. And then they manually combine all of this data and try to make best guesses. But as humans, we make mistakes, right? Sometimes we make really good guess with experience, based on experience, but sometimes we can become too emotional and we can order too much heat because we want to be on the safe side a little bit too much. Some people on our team might be a bit more risk adverse, so they will make different decisions than the typical risk takers that we might have on the team. And that's where AI comes to play. And what we did, we trained, I think, 50 models, which we deployed across the whole infrastructure in the city. And those models got trained on the historic data, meaning what supply temperature they typically ordered, in which month, what's the heat consumption in the city predicted over the next few hours, what's the weather forecast, and all the other parameters that we were able to read this from SCADA, from online systems, and from any other data storages that we had at the energy utility company. And what we enabled through that, in the first wave, we enabled predictive maintenance. So when we analyze the data from all the parts of the energy utility infrastructure, like pressure at the pumps, the speed, flow of the water, the speed, how fast we should deliver heat, what's the weather forecasting, and so on. Then based on that, we can predict certain failures. And then for the operational team, it means that they no longer had to, send over the team across the entire city to monitor different nodes, in cycles. They can prioritize their job based on what would be the highest risk and where. That's the first thing. So predictive maintenance or proactive maintenance, we call it. Another thing is to optimize the cost and the operations of the energy utility company itself. And by doing that, we can make suggestions, data-driven suggestions, to help the energy utility company optimally order the supply temperature, set the pressure thresholds across the entire infrastructure, so that we no longer waste too much of the energy. So, it's like at Toyota, just-in-time production. That's what we enable at the energy utility company, that it's just-in-time supply temperature. We request the temperature that's needed for the next few hours based on weather forecasts, demand prediction, and operational information of the infrastructure. So that's what we've been doing for the energy sector, and for that solutions, we already have partners that can deploy the IoT infrastructure, the server infrastructure, and Bytec provides AI, and we have a know-how here. So if that somehow is close to your areas, we're looking forward for local partners with whom we could work in this particular cases. So reach out to Synera team as we're ramping up. Anyway, I said that the typical infrastructure for AI inference is small PC with just a CPU. That's true for most of the industrial cases. Talking about weather forecasting, talking about visual inspection, sound analytics, maybe predictive maintenance. Sometimes we need to expand our servers and grow them to more powerful machines like SC450 referred previously, which can take it's a single socket server, so it can take like one Xeon CPU and two GPUs full size. But in other cases, like this one that you can see on the screen, we need more powerful machines. And this server powered by 4 H100 GPUs from NVIDIA and 2 AMD processors, totaling in 128 cores. This one is used for AI that is intended to predict the results of industrial simulations, in that case, CFD, computational fluid dynamics. So that's just to give you an example that the infrastructure can easily scale from tiny little PC to powerful HPC clusters and superclusters, clusters. One new word popped up, inference. So as I said, before AI can do something, you need to train AI. The process is called obviously AI training. But once AI is trained, we have model. And when the model is executed, when it can do something, or it's doing something, the process itself is called inference. So when I say, or Mariusz later, we say inference or inferencing, meaning that means that the trained model is doing something, turning images into information, for instance. Anyway, you can read more about the case study on the link at the bottom. I think the link on the bottom, but to summarize that part, few of the benefits. So first of all, you accelerate the data analytics. Obviously, right? You train the model to do something with your data, and then it can do it much faster than typically humans would do, because we're talking here about processing huge amount of data. You automate the quality inspection. You optimize operations and maintenance. You can, most importantly, reduce unnecessary inspections. That's really important in predictive maintenance settings. Some say that with just humans at the production line, we can ensure the quality roughly around 80%. Of course, it depends on the day, on humans, on the team quality, and so on. But with AI, we see that humans plus AI is like, giving them a bit more advanced calculator, right? So some estimate that we can reach the quality or accuracy with of around 99%. Continuous monitoring, right? So AI can work 24/7, 365. Easy replication. When you train AI for your one production line, chances are that, off-the-shelf solution will work on multiple other production lines. Of course, there might be different nuances, like a little bit different sound or different, lighting condition, but that can be calibrated, and Mariusz will talk about the process later on. Continuous improvement, something Mariusz will cover in his part of the presentation. AI can train, retrain, calibrate, recalibrate until it becomes your perfect, lovely solution. Anyway, enhanced productivity, that's what we see from analysts. Customization and adaptability. When we as humans evolve, right, all the time, and our processes do the same. When we change the process, when we add more products, add more flavors, AI needs to adapt itself, and that's what's possible with AI. Reduce downtimes, data-driven decision-making, consistent quality control across the whole organization. That's all that comes as granted. But hey, how to start, right? So Mariusz, maybe you can tell a few words about how to start, because I'm the one at the maze. So
yeah, exactly. So thank you, Marcin. So Marcin already told us about a few examples about when we can deploy AI, how we can use it, and all those stuff. But now maybe let's focus about our daily job. So how we can train it, what does it mean using AI from our point of view, what does it mean training, and how we are deploying this stuff to the customers. So first of all, probably you can find a lot of opinion in internet about AI, something starting from that this is solution for everything, going to that to the opinion that it will take our job or even kill us. So probably this is the two extremum where you can find, and probably you have a feeling that the real or the truth is something in the middle. So in ByteTech, we are treating or using this AI or thinking about it as a tool, and just the tool that can help us solve some problems. And on the next slide, yes, I need your help, Marcin. So I'm switching this slide. All right. Okay, so there's a few motivation of using the AI. Some people would like to use it or would like to deploy it because the neighbors has it, some competition already has it. But from the mundane problems, on ground problems, you can find that there's a lack of people. You cannot find the experts of using or people using some stuff. For example, like Marcin told us about this paper mill industries. There's a lack of people that would like to monitor the process, but it's not very interesting. Let's truly say. Some other businesses has a problem with the staff and the hire people, huge rotation. They need to train the people all and over again. So the companies already find the solution and would already know it, that they need to automate the process, especially that we have a lot of new jobs in the market. We have YouTube channels, we have other experts, YouTube experts. So there's a lot of new jobs that people would like to do, and we need to automate the old one. And now, what does it mean, and what is the good strategy for implementing the AI? So first of all, we need to find the use case. So this is the something that we need to discuss with the clients. We are helping them to analyze their problems, their processes, and then we need to talk together to find the real case scenario, how the AI can solve their problems. And all examples you had during the marching sessions. Then now we can answer the questions. Why AI now? So the answer is very simple, and Marcin already told us about that we are, let's say, data-driven society. So we are storing the data everywhere. And as a perfect example, we can say about the photographs. Probably the few people in the audience already remember the first shots or first cameras that we have with these films, analog one. We have only 36 photos, and it needs to be done for the whole trip. Currently, we can put and we can take a lot of photos, hundreds, thousands from one trip, and there's not a problem. The problem is how to find the exact picture that we would like to watch. And the answer is AI. So if we have a lot of data, we need a tool to search the information inside it. And the answer is the artificial intelligence. And now on the next slides, I will describe a little bit of background of our work. So we can, let's say, split vertically of our job to the few, or let's see, three main aspects. First of all, we need a sensor, because artificial intelligence are very similar to our senses. So to work to, we need the senses, so that we can feed the artificial intelligence. As for us, it's ears, eyes, and all those stuff. For the artificial intelligence are the cameras, microphones, and etc. Next, we need the brain. So the brain for the artificial intelligence are the models with the computers. So this is the bottom line of the AI. And of course, in the middle, this is the human. There are experts that we need to talk with and take the best information from their experience, so that we can train the model from. And now, what does it mean to take the data? So first of all, when we are entering the company, we need to talk to the people, and we are searching for the data or asking the questions, what kind of data you already have in the company? None. So you can expect that the answers are always the same. We have the data. We have all data you need. Okay, we are suspicious a little bit about that, but of course we need to agree that the client has already data that we have. But during the negotiation or during the process of looking into data, then there are some missing parts, because some employees put the data into the Excel, some other put it into the paper and are already missed somewhere, and some other are only in somebody's heads and already left the company. So you can imagine that there is a lot of holes in the data. And the funny story is that a lot of projects that we already have, there are already some additional benefits of using the AI, because during our work, a lot of holes are just closed, because we are just fulfilling the information that they already have missed. So this is the first thing. We need to collect the data. We need to find all the sources that we can find it. Then then this is another part, data cleaning. Data cleaning means that if we already have the data, we need to prepare them to put it into the models. We need to reshape them. We need to prepare them or scale. We need to exactly prepare the data to put it into the model so that we can take the information from. And when the data is prepared, then we can try to train the model. And answering one of the questions that we had on the chat, how long does it take to train the model? So it really depends. So this is exactly what the answer was, that sometimes it's a month, but it can be only the month. But for us, training, starting from collection data, cleaning data, and then to train it. So this is whole the process. And it's unfortunately, it's not like that when we, after the first training, we got the final answer. It's impossible. After the first training, we have some answer, and then we need to calibrate all the process. So this is another process on our line, the calibration. We need to find out if the data that we got is enough. Maybe we need to change something. Maybe we need to put the filter before even training. So there's a lot of solutions that we can try to make even more information from data that we got. And after this iteration process, then we can get the final solution that we can deploy on the server. So this is how it looks like. It's not the easy stuff. And you need to think about AI, like the work with the data. And you got the tool for taking the information from. This is exactly.
Looks like the most challenging part is related to the data cleaning, collection, and preparing, right?
Yeah, exactly.
The training itself, right? The training itself. One thing that I would like to emphasize here is that the biggest advantage of that process is that you don't need to waste time on building the products from ground up. We already have the products, so that's where you see Aplikace AI product. I think that saves you 2 years, 5 people development team, for instance, effort, roughly. As Mariusz said, the major focus for that process is focus on the right data to prepare it for the training. And the training time Mariusz referred to is by Bytelex definition, meaning the whole thing, like collection, cleaning, training, calibration, retraining, calibration, and so on. Anyway, moving forward.
Yep. Moving forward, it means Marcin already mentioned a few definitions about the AI inference, AI training. This is exactly what is inside the AI. So first of all, the training, it's all about this, what I described it on a previous slide. So the process about the data collection, data cleaning, AI modeling, and the calibrations. All those stuff, we need a really huge machines so that they are able to train these models in a and time conditions. So we need a servers, a huge one with the graphical card, so that we can find this answer in a short time. But after we got the model and we would like to get some information from, the process is called the inference. So inferencing meaning that I already trained the model and now I would like to use it. And for using, as Marcin said before, we need just the simple machines like this Lenovo SE50 or other edge servers. And we are the company that specializes of building these models on the edge, because we have already a subset of models that we can reuse for our clients. And the advantage of that is that we are not we don't have to use the cloud. Okay, we can put it into the cloud, but it's not the mandatory. So you probably heard a lot of problems nowadays with the clouds. There is a lot of problems with accessing data. Sometimes it's missed. Sometimes there is too many data, even if the users thought that they are already erased. But sometimes magically it happened that the cloud provider is putting some data back. So, you know, this cloud is not solution for everything. So we specialize to build the models in the edge scenario, so that you have a guarantee that whatever will happen with your data will stay in your environment. Yeah, exactly. And what does it mean, this inferencing? Because this is the most important part for the clients. So, as said before, the AI and inferencing part is just of using the sensors. So we need to put the sensor on production line, on the production process, or we can use already existing, like for example, for weather forecasting, or some processes that we have already stored in our database. It doesn't matter what the sensor is. We need the data because the AI is working on the data. The next thing is we need to install the brain. So for us, it's a model with it's a PC or a edge server with the model. So this is the brain that we need to install on the edge. And the final, we need to get the information. So we are preparing some kind of the interface between the response from our model to the system front end to the clients. So the most important part is here is that we need to prepare the data or the information in a way it's understandable in the customer solution. So, and this is all that we need to build for the client at the end of the process. And now a little bit text. So how to prepare. So it depends about how maturity the client is. Very often we need to start from the beginning, so we need to build this scenario. Sometimes clients are asking us to help to identify the places where they can put the AI or identify the places, but their processes are not good enough. So this is the clients is not very mature with the AI, so that with such clients, we are going to their premise, we are organizing some meetings, and we are trying to familiarize with their problems, with their process they have inside, and then we are starting discussions about how and what the AI can put into their process so that they can have all advantages of having the new tool. And all advantages, I meaning the thing that Marcin already told us about. So it's about the saving the money, saving the time, training the new guys. So it means the real cost effectiveness in the client's premise. Of course, after that, we need to talk about where we can put the cameras, where we can put the sensors. So we need to discuss with the clients about all things and describes all the things that we will need to install our solution in their premise. First steps in the projects. So we need to put all the information that I already shared with you with our process, and we need to start discussion with the clients. And this very iterative process. After we know and we choose this scenario we would like to implement it in, we need to find, of course, the data. We need to talk to the clients. What does it mean, the good train AI for the client? What does it mean? What is the exactly goal that clients would like to achieve with the AI? And after this simply online or offline quality questions and other sessions, we are trying to answer all those questions that in the end we will need to put into our models. So this is the first steps. So you can think about it, about discussions, elaborating, and all boring stuff that we need to do with the clients. About the cost and deployments. So this is also some interesting stuff that you can think about it. So how much it costs to install or deploy some AI into our premise. So it's about licensing. So as already mentioned, we have a lot of and a bunch of models that can be used that can be used in the client's premise. So this is something that we already trained during our all years of working, and we have this in our let's say premise. This is something that we put it into the license, and you can get it just like that. The another thing is that we need to put some information, or we need to put it in data into these models. This is something that you are putting it into that. So we are collecting the data from your premise, and we are promising that this data will keep you will be stored only in your premise. We are not putting it, taking it out. We are not putting it into the clouds. This is your data that we keep into your environment. And after that, we are, of course, you need to think about the cost of the software that you need additionally. For example, when you need to show it, for example, in your production line, you need to think about the hardware, some servers, some edge servers. So all these costs need to be taken into account when you would like to put some new solutions into your premise. But of course, it's always the same. Yeah. So if you are thinking always about putting the new tool into your factory, you need to think about the hardware, software, and some licensing, for example, for the models. So this is like it is. Of course, after that, it's always cost about this deployment. It's also cost some integrations, but with companies like Bytech, you have always promised that all will be covered by us. You need to just hire us. So I think that it's all about that. This is also a few stuff that Martin will also describe here about the data and storage.
Yeah, so just a few examples about data storage for the training and how the computational effort scales across different solutions. So you see, like, depending on the use case, for the energy sectors, just for instance, we're talking about hundreds of gigabytes of data that needs to be processed all the time in real time, right? We're talking about 3 times that size for the data used for training. For CFD simulations, we're talking about the terabytes of data that we typically deal with for the training. And then again, gigabytes of data that is used for the inference. And the infrastructure really varies, like all the way from small PCs, small form factor PCs like SE50 to single nodes and with many GPUs, or clusters, super clusters with many nodes. Same goes for the computational effort. Like typically for the inference, we rely on i7 or Xeon. By the way, all of our products are fully optimized through OpenVINO, Intel infrastructure, as well as NVIDIA libraries. So, but typically don't need that much of the performance that we need to go for inference with GPUs. But for the training, it's typically a must, like L40, H100, depending on the workload. Again, fully scalable, both training and inference, depending on how many cameras you need to install, how many microphones, what's the process that needs to be monitored. Just to give you a few examples, like for typical quality inspection in the paper mills, we typically go with i7, single tiny PC like the SE50. For the energy sector, for all the models that I mentioned earlier, for predictive maintenance, we go with something like SE450, or maybe single node configuration with 2 Xeons, 2 AMDs, and then 2 L40 NVIDIA camera GPUs. But for most complex simulations like CFD, we might go with many H100 GPUs. So that's just the scale. It will give you also a ballpark of the cost of the infrastructure. But as Mariusz said, the cost of AI product consists of 2 components. One is one-off, that's typically related to hardware reselling, infrastructure reselling, all the other software that you might need, like math software, CRM, ERP, anything else. Then there's a one-time fee for the model training, calibration, data collection, data cleaning, all the process that Mariusz nicely described. And then there's a license fee, which is an annual license fee in case of our products. No consumption-based fee, no cloud-like calculations. It's a flat rate annual per installation fee for access to our products. And that's hopefully that helps you go through the maze and not to be lost again when you hear AI. Okay, what's the strategy? I know. I first need to work with the data and then call scenario and byte, like, right? So that's how it typically goes. If you want more, you can go to our website. You'll find more information there. You can find us on YouTube, on social media. We have a blog where we describe deployments, and hopefully you'll find some interesting inspirational articles there. And let me quickly skip through that because right now it will try to play all the videos. But anyway, if you have questions, reach out to us, and I think we'll have some time for questions and hopefully some answers. So thank you very much, and it's time to raise a hand.
Thank you.
If you have anything. You're on mute, so.
Did you hear me?
Yes.
Yeah, okay. Thank you, Martin, and thank you, Mariusz, for your presentation. And I will switch to Czech for a few words. Chtěl jsem dodat věci, které by asi měly zaznít. Děkuji panu Veselému, že se zeptal. Prosím vás, v tomto případě není implementace AI nějaký proces, který se trvá roky a investujete do toho miliony. Jo? Samozřejmě záleží na rozsahu projektu, může to tak být, ale vřele doporučujeme začít jakoby nějakým procesem, který u vás ve společnosti najdete. Jo? A řekněme, ty náklady se budou pohybovat v desítkách tisíc eur. Jo? Neberte mi prosím za slovo, že to bude 10 000 eur, ale bude to v tomto řádu. Často slyším, že prostě se do toho musí nasypat miliony anebo desítky milionů, aby to něco dělalo. Není to tak. Velkou výhodou je, že si touto licencí a spolupráci s ByteLake kupujete neskutečně mnoho zkušeností, které oni s implementací AI už mají. Jo. Takže to je první věc. Takže nejsou to jakoby velké peníze a určitě se poměrně rychle vrátí. Za druhé, ještě jednou panu Veselému děkuji, není to implementace v letech, ale některé implementace mohou být v měsíci nebo v měsících. Jo, to znamená, jestliže to teďkom se rozhodnete, tak určitě prostě je ten prostor, ByteLake má na vás prostor a pomůže vám s tou implementací a budete mít poměrně rychle výsledky. A za třetí, zcela to odpovídá, tak jak jsem to už říkal na začátku, dotacím, které se vypisují pro digitální podnik. Prosím vás, kde Evropská unie vám uhradí až 60% nákladů. Jo? Takže určitě jako je to i financovatelné z pohledu toho, že ještě 60% můžete dostat jakoby zpět. A asi se jako ITáci shodneme, že určitě je lépe mít jako všechny ty data u sebe, jo, protože tady nedojde ke zneužití dat, nemůžou doplout ke konkurenci, nemůžou být poškozena a tak dále, budou u vás ve vaší infrastruktuře, takže další vaše výhoda, prostě bude to běžet jenom u vás. Jo, nikde jinde si data nebudou povalovat a jak to kluci ukazovali ve finále, ty zařízení, které budou tu natrénovaný model provozovat, nejsou žádně extrémně náročné, ať už počítače nebo servery, samozřejmě v závislosti na potřebách. Jo. Takže to jsou jako takové výhody, které jsem chtěl pro vás v češtině shrnout. Budeme rádi za nějaký, jakoby případně, co to je? Aha. Nevím, co to píše tady nějaké i...
Podle mě on snaží nějak...
Co najít?
Ono se to snaží jako pan Višně asi rozpoznat, co říkáte v češtině.
Jo. Tak se tam objevili nějací naši zákazníci, jejich názvy. Takže děkuji. And I have few questions to the maybe Martin or Mariusz. How does AI know what the decision to make?
Yeah, so it's I can take this one first. So it's it really depends on it's a plethora of factors. First of all, as we said, AI needs to be trained. So from the training data set, it can, draw certain conclusions. But then how to know how to make the decision? It's from the real-time data that goes into the trained AI, meaning model. So when you connect camera or a microphone or any sort of data to your trained AI model, then based on what it was trained on and what it can read from the sensors, AI can make a decision, and that's how it knows how to make a decision, right? But we really emphasize that it's really about humans plus AI in most of the factors, and AI helping us automate certain things, right? So that's hopefully answered the question.
Okay. What is the edge AI? Please.
Yes.
Some advantages.
Yes, I hope that I was able to answer that question about the edge AI. So you can imagine that we have two things that we can think about computational. One is in the cloud, meaning that all the computation is that you put into the servers that is stored somewhere in the internet, meaning it can be your premise, some other location, or maybe it will be some kind of the delivery provider, or let's say cloud provider, meaning the Google, Microsoft, Amazon, and all those stuff. So all you are doing or computing in the cloud is meaning that it's you need to send the data to other let's say vendors, and then you can compute them. On the edge, it means that all the data are stored in your premise, and all the computational is done as close as process as possible. So it is as close to the process as possible. So meaning that we can put a small edge servers near the process that you would like to monitor. Let's take the example, for example, of this paper mill industry, where we put the cameras, we put the hardware very near this table where all the process is. And the computational is just like nearby the process. So all the data is safe and is exactly in your premise.
Okay, perfect. Thank you for your time, Martin. Thank you for time of all which attended of this meeting. Děkuji vám za vaši účast. Já pevně věřím, že jsme vám přinesli nějaké nové informace a můžete ve svých firmách a ve svém IT přejít na nějakou novou úroveň, která vám pomůže být více efektivní. Určitě dále můžeme společně individuálně konzultovat. Kontakty na mě a na kolegyni Koláčkovou najdete na webu. Ten záznam dostanete následně do mailu, můžete ho, doporučuji, předat jakoby vašim kolegům, technickým ředitelům, managementu, aby uchopili tu šanci být jakoby takzvaně in a začít co nejdříve s AI, abyste zvýšili svou konkurenceschopnost. Takže za mě děkuji. Chtěl bych vás pozvat ještě na závěr na další webináře, které budeme navazovat v srpnu. Tentokrát se budou týkat dotací, o kterých jsem mluvil, takže se dozvíte, co všechno jakoby, a jaké dotace můžete získat. Jeden ten hlavní dotační titul už jsem tady zmínil. Pak tam bude nejspíše velmi atraktivní téma, které začne už v dalším týdnu, to je VMware. A máme pro vás připraveno v srpnu srovnání VMwareu a alternativ, které můžete začít prozkoumávat nebo používat po zdražení a změně licenčních podmínek VMwareu. No a dozvíte se nejspíš něco také o open sourceovém free helpdesku. Takže buďte s námi, my budeme s vámi a děkuji všem za pozornost. Mějte se krásně.
Taky vám děkuji, mějte se, nashledanou.
Děkujeme.
Děkujeme, thank you.
Bye bye.
Bye.
Do widzenia.
Do widzenia.
Bye bye.